Hey there. So, when you think of the Great Lakes, what comes to mind? Probably something calm, right? A beautiful, serene stretch of fresh water, a perfect inland escape. But what if I told you that just beneath that peaceful looking surface lies a danger that can actually rival, and in some really specific ways, even exceed the open ocean?
I know, it sounds like a bit of a stretch, doesn't it? I mean, how could these lakes we know so well really be more dangerous than the huge, mighty oceans? Well, the evidence is pretty startling, and it all kicks off with this massive gap between what we think we're looking at and what's actually going on out there on the water.
And this right here, this really gets to the heart of it all. This huge disconnect between perception and reality. We see these gentle, safe-looking lakes, but you talk to mariners, you talk to scientists, and they see something completely different. They see a treacherous, wildly unpredictable force of nature. So let's dig into why that is. It all really starts with that deceptive serenity. And that leads us straight to the science behind these incredibly violent waves. Because it turns out they are fundamentally different and, yeah, in some ways, way more dangerous than what you typically find out in the middle of the ocean. Okay, so here's the key difference. Ocean waves, they're often these long, rolling swells that have traveled for hundreds, maybe thousands of miles from some distant storm. They've got a rhythm to them. But on the Great Lakes, the waves are born from local storms, which makes them steep, really choppy, and dangerously close together. In a word, they're just chaotic. You know, a mariner named Paul Christensen put it perfectly. He said it's like the difference between a pool and a bathtub. In a confined space like a lake, even a really, really big one, it takes so much less energy for a storm to just whip that water into an absolute frenzy. And that means the waves can build up with terrifying speed. And this danger really hits its peak in the fall. So here's what happens. You've still got all that warm water left over from the summer, and then bam, the first real blasts of cold autumn air start rolling in. That huge temperature difference creates massive instability in the atmosphere, and it just pumps energy directly into the water, building these monstrous, totally unpredictable waves. And that chaotic wave behavior, it leads to a threat that you almost never see on the ocean. We're talking about water that can literally break steel. See, it's not just about how tall the waves are, it's that they are incredibly close together. And for a long ship, like a freighter, that wave frequency creates this uniquely catastrophic situation. So I want you to picture this. You've got this massive 700-foot freighter. A wave lifts up its bow, and the very next wave lifts up its stern at the exact same time. For a terrifying split second, the entire middle of that ship is just hanging in midair, with absolutely no water underneath it for support. The sheer weight of the ship, plus its cargo, puts this unbearable stress on the hull, and it can just snap right in half. And listen, this isn't just some wild theory. This is exactly what happened to the SS Daniel J. Morrell. It was caught between two waves, just like we described. The structural stress became too much, and the ship just broke apart. The power of these waves is just immense. And of course, this immediately brings to mind the most famous Great Lakes tragedy of all, the sinking of the SS Edmund Fitzgerald back in 1975. That disaster really cemented the legend of the lake's unforgiving nature in everyone's minds. But believe it or not, the waves are only half the story. There's another, more subtle threat that comes from the water itself, and specifically, the fact that its lack of salt can become a huge liability. I mean, as you can see, it's pretty simple science. Freshwater freezes at a higher temperature than saltwater does. This makes a really critical difference during those brutal Great Lakes winters. The spray coming off those choppy waves freezes almost instantly when it hits the cold steel of a ship. And we're not just talking about a little layer of frost here. This is about tons, literally tons of ice building up, and often unevenly, all over the ship's superstructure. This makes the whole vessel top-heavy and dangerously unstable in seas that are already treacherous. It's like a silent killer that can capsize a ship without any warning at all. So, after hearing about all these hidden dangers, the takeaway is pretty clear, right? These inland seas demand our respect. Understanding these unique forces is absolutely the key to staying safe. So let's just quickly recap the three big, unique perils we've talked about. You've got the steep, choppy waves that form with just alarming speed. You've got that unique structural stress that can literally break a ship in two. And you've got all that heavy ice piling up from the freezing freshwater spray. Now, it's totally true that weather forecasting and technology have made sailing the Great Lakes a lot safer than it was back in the days of the Fitzgerald. But the experts are crystal clear on this one point. You can never, ever afford to underestimate the power of these inland seas. The fundamental dangers are still there. It really makes you think, doesn't it? The Great Lakes show us that even the most familiar, seemingly peaceful parts of our world can hide this incredible, unexpected power. It makes you wonder, what other serene landscapes do we just take for granted? That's something to ponder. Thanks for watching.